Look at our planet today, vast, deep, and tranquil. These gentle blue oceans cover most of the globe, providing a peaceful cradle for all known life. But 4.5 billion years ago, early Earth, Gaia, was a glowing, hellish sphere of liquid rock. The young solar system was a violent, crowded shooting gallery. Constant bombardments from runaway meteors and rogue asteroids generated enough heat to keep the entire planet melted in a global magma ocean. Then, a rogue planet the size of Mars named Theia slammed into the Earth at thousands of miles per hour. The impact was cataclysmic, shattering the incoming planet and ripping away a massive chunk of Earth's young mantle. Gravity quickly corralled the resulting ring of red-hot, vaporized debris. Over just a few decades, these pieces fused together to become the Moon, while the Earth remained a churning ball of liquid fire. On a world this hot, liquid water had no place on the surface. To form the oceans we see today, the water first had to be built into a toxic sky, trapped as gas until the planet was ready for it to fall. Eventually, the celestial bombardment slowed. As the frequency of impacts dropped, the surface of the Earth finally began the long process of cooling from a fiery red to a dull, dark gray. While molten, gravity sorted its internal layers. The heaviest materials, iron and nickel, sank deep to form the dense metallic core. Simultaneously, lighter rocky silicates floated to the top, cooling into a thick mantle and a thin, fragile basalt crust. This new crust acted like a seal over the boiling mantle. Deep beneath the rock, internal heat from radioactivity generated immense pressure that had nowhere to go. Massive volcanoes erupted across the globe to act as exhaust valves, releasing the trapped gases held deep within the Earth since its birth. These eruptions filled the air with carbon dioxide, nitrogen, and methane. But the most critical component expelled by the volcanoes was water vapor. Staggering amounts of it hissed out from the mantle into the sky. Because the surface was still too hot for liquid to pool, the Earth's future oceans existed entirely as a superheated, suffocating greenhouse gas. As millions of years passed, the upper atmosphere continued to cool. The global temperature slowly began to drop toward a critical turning point. Eventually, the air cooled enough that it could no longer hold the water as a gas. The vapor began to condense into liquid droplets, forming heavy, planet-wide clouds that wrapped the Earth in a thick blanket. These clouds grew so dense they blocked out the sun entirely. The planet was plunged into a dark, eternal twilight. Then the first rain began to fall. Torrents of water smashed against the jagged volcanic rock, turning to steam in a relentless cycle. This deluge continued for thousands, perhaps millions of years. It was an apocalyptic storm of unimaginable scale, pouring water over the landscape without a moment of relief. As the water rushed over the volcanic rock, it dissolved minerals and pooled into the vast, low-lying basins of the crust. This million-year storm successfully quenched the hellish red world, transforming it. This new world was unrecognizable. The first global ocean was an olive-green expanse, reflecting a thick, carbon-heavy orange sky. The water was rich with dissolved iron and chemical compounds washed down from the volcanic rocks, creating a chemical soup unlike anything in our modern seas. The same violent forces that shaped the planet now provided the stability needed for life. Deep inside, the new iron core generated a powerful magnetic shield, protecting the surface from the sun's fierce solar wind. Further out, the gravity of the newborn moon steadied the Earth's erratic wobble, establishing the stable seasons that keep the planet's climate in check. After millions of years of rain, the surface was finally covered by the vast, chemical-rich global ocean that would serve as the ultimate nursery. Sheltered by its magnetic field and stabilized by its moon, this restless world was finally primed. In the deep, dark vents of the seafloor, the first sparks of life were ready to begin.